demo video to show you how the data is collected for the Equilibrium lab. We have 4 solutions that we're using today in this lab, and they are as follows. We have a solution of iron 3 nitrate, ferric nitrate, that is at a concentration of 0.2 molar. We have potassium thiocyanate, which is at a concentration of 2 times 10 to the minus 3 molar. We have a second solution of iron nitrate, which is at 2 times 10 to the minus 3 molar. And you can see that this visually looks quite different from the 0.2 molar iron nitrate, which is very concentrated. And finally, our fourth solution is a solution of nitric acid, which is at 0.5 molar. For the solutions that are prepared for Table 1, we'll be using the concentrated iron and the dilute potassium thiocyanate. So this table had 4 solutions that you had to prepare. So I will demo and collect data on the first solution, and then I will show you what the rest of the solutions look like. So this is the solution 1, the standard, and table 1 that I'm preparing now. So I want 5 milliliters of the concentrated iron. And I have some of it poured out into the beaker here. To this, I am going to add 0.25 molar potassium thiocyanate. And just like you did last week, you would see the formation of the blood red ferric thiocyanate complex. All right. The other thing that goes in here is the nitric acid, 4.75 mils. I'm going to change my pipette. And some of that poured into this beaker here. This is my nitric acid. And the last thing that goes into this flask is going to be just reverse osmosis water from the lab. Taking a little bit of time to do it this way, but I want to make sure that I don't overfill the solution. Right. And for mixing my solution in the volumetric flask, I'm going to invert it. And there we have it, a fairly pale red solution of the ferric thiocyanate. And as a comparison, you can see what solution number 2, 3, and 4 look like. So you can see that there is a color gradient where it looks like you're making more product and you're getting more of that red ferric thiocyanate color. So we'll collect data on all of these, but I will show you how the software works and collect some data on one of the solutions. I also want to just show you what the solutions in Table 2 look like. So the solutions I just showed you were for Table 1, which you will use to make your Beer's Law plot. The solutions that I will show you now are your equilibrium solutions that you will use in your calculations for the Rice tables. So these are prepared according to the directions in Table 2. There are 4 solutions once again, and these are labeled A, B, C, and D. You can still see a little bit of a color gradient with A having a lighter color than D. And this would make sense if you looked at the values in Table 2. So if you think about Le Chatelier's principle, you are adding the same amount of iron nitrate to all of these. So you are adding 10 mils this time of the dilute iron solution. So 10 mils of dilute iron solution went into all of these. And then you had an increasing amount going from, I believe, 4 to 8 mils, right? So there's an increasing amount of potassium thiocyanate in all of these. So if you think about it in terms of Le Chatelier's principle, it makes more sense that you're seeing more products. So these are all at equilibrium, and you'll see what that means in terms of the race table calculations later. So again, to emphasize, solution A through D are the solutions that you're preparing to get the absorbances for the race table. And you have a separate set of solutions that we are using for the Beer's Law that are labeled 1, 2, 3, and 4. I'm going to move some of these out of the way. And move my spectrometer closer. So I have a Vernier Go Direct SpectraVis Plus, so that is the name of the spectrometer we're using here. And I'll probably pick a solution that's a little bit of a deeper red color to show you rather than number 1, because we're just doing this mostly to get a sense of what the data acquisition process look like from the software end of it. So I'm going to minimize this and then open up our spectral analysis program. And move that over so that you can have hopefully a little bit of a view of both things happening. All right, so on the screen, you'll see my spectral analysis program opened up, and you can see that I'm going to collect absorbance data, and I'd like the full spectrum, so I'm going to choose that option. And it goes through a little bit of a warm-up. And while that's warming up, I'm going to go ahead and grab my cuvette. So my blanking solution is going to just be RO water, because that's what we're solving today. And then I'm going to go ahead and fill a cuvette up with a sample. It takes a little bit of time for the lamp to warm up, and that's what gives you a stable absorbance reading. And once it prompts me to enter or to place the blank cuvette in the spectrometer, I will go ahead and do that. And I will ask it to finish the calibration. All right, so it's been blinked, and I'm not expecting to see anything on the screen because this is just used to subtract any color that would be there. In our case, we have water, so it's a colorless solution. So it's mostly just a procedural thing that we're doing to make sure we have a blank in there. All right, so we have our solution, which is a red standard. So that is going to go in here. And so the absorbances for all of the solutions today will be provided to you in a data table. So this is mostly just to look at what the data collection looks like. All right, so I'm going to hit collect. And you can see that my spectrum popped up pretty quickly on the screen. I'm going to go ahead and hit stop. And I'm going to click on the screen. And I'm going to look specifically for The lambda max, it looks like in this case, is around 456, but the handout actually has us collecting the data at a slightly different wavelength that's close to lambda max, which is 470. And so I'm going to just use the arrows to get there. You can see on the table, probably the closest I can get is 470.7, and so that is our number that we would put into our table. And we can go ahead and switch out our solution and collect more data. All right, so you have a sense of both how the solutions were prepared, what the stock solutions look like, and also how the software collects the data here.